Hi everyone, thanks for joining our webinar today on zero-day read-only cloud apps. Today we have Rich Campagna, CEO of BitGlass, and Mike Shurik, VP of Product at BitGlass. So before we begin, I want to mention that if you have any questions during our webinar, please make sure to type them in and we'll get to as many as possible at the end. And you can also find some downloadable material in the attachments and links section, so make sure to check that out. And finally, this webinar is being recorded so you can view it on demand afterwards. But without further ado, let's get started. Rich?
Thanks, Annie, and thanks, Mike, for joining. It's been a long time since the two of us have done a webinar together, so I'm not only pumped up about that, but I'm pumped up about the topic today as well. So I think a really relevant topic that kind of speaks to the heart of how enterprise cloud adoption is really changing and evolving. And this evolution is really impactful for how people plan their security strategy moving forward. And so we'll start here with the problem statement that we're looking to address. And I think, at this point in, it's probably at least 3 or 4 years into, many organizations adopting or at least talking about adopting the public cloud. And at this point, this is kind of one of the key things that people are looking to address when they move to the cloud. Right? You have cloud applications, both managed applications, sort of those well-known cloud apps like Office 365, Salesforce, and Workday, and also a set of unmanaged applications as well, those so-called shadow IT applications that employees may be using outside of the control or the oversight of IT. And connecting into those applications are a whole host of both not only managed devices but unmanaged devices as well, right? Everyone knows that an app like Office 365 or Salesforce is publicly accessible from anywhere on the internet, which means that your employees are not only using their managed devices to connect to these cloud applications, but unmanaged devices as well. And that connection between whether it's a managed device or an unmanaged device and these various different types of cloud-based applications represents a data leakage and threat risk to your organization. The challenge is that your legacy security technologies are rendered powerless when a user connects from their personal, let's say, iPhone over a Starbucks internet connection to an app like Office 365. There's really nothing that your firewall investments, your premises DLP systems, or any of the legacy security technologies that you've invested in can do to impact that transaction and to mitigate the risk of data leakage, malware, other types of threats facing this type of scenario. And so this is the problem that many of you have been dealing with over the last couple of years and perhaps continue to struggle with today. But there's a twist here that's happening now that's kind of really making this challenge even more difficult to go after, and that's the expanding cloud footprint that that we're starting to see across the enterprise landscape. So you see a vertical line here in the center of the slide. To the left of that line are a set of pretty well-known cloud-based applications that are adapted across a broad range of different industries and have been deployed now pretty heavily in the enterprise for at least a couple of years. Office 365, of course, has led the charge, where pretty much every organization on the planet has either looked at or has rolled out some portion of Office 365. And there have been a set of technology vendors known as cloud access security brokers that have been built to address that set of applications. And of course, BitGlass is one of those types of vendors, a cloud access security broker. And a number of organizations have rolled out these products over the last few years to build security compliance and threat protection controls around that kind of fixed set of well-known cloud-based applications. The challenge is there's a much broader set of applications out there, and they're starting to become more and more prevalent in the enterprise, what we call the long tail of SaaS applications. In some cases, these are managed applications. So it may be a managed application in healthcare. You see logos up there like Epic and Cerner as examples. These are medical record applications that are starting to move to the public cloud. You see a lot of internal applications being moved and hosted on public infrastructure as a service platforms like AWS and Azure. And you also see, both custom applications as well. You also see off-the-shelf software like analytics packages and BI tools being run in the public cloud as well. And in all these cases, these tens of thousands or even more applications, they all have many of the same sort of security and compliance challenges that you've had to address with that small group of well-known cloud-based applications. The challenge is when you move from something like 10 apps to tens of thousands of applications, it becomes completely unwieldy and very difficult to get a handle on how do you write policy for all these different types of applications. How is a user connecting into an IT sanctioned or managed application going to be governed in the same way or in a different way than that same user logging into an unmanaged application like their personal Dropbox account? Now, both of those represent data leakage and threat risk, but the ways that you can handle them and the ways that it's appropriate to handle them may vary from that managed application to the unmanaged application. And so that's kind of the heart of the webinar today. We're going to talk about sort of the sets of technologies that people are putting into place for managed apps and unmanaged apps, how the sets of policies around those applications are different as you kind of make that transition, and how you can take things like a totally unmanaged application that your organization has never seen before and may never see again, and put some controls and policies around that so that you're really doing a comprehensive job of protecting against data leakage and threats. And so, this is just kind of a summary of that problem, but the couple of areas that we're going to talk to quite a bit. New applications. There's, maybe 20, 30,000 known cloud applications today. There may be 50,000 a year or two from now, and 100,000 a year after that. And so how do you address that challenge with the fact that there are new applications every day, and you don't want to be in this role of playing whack-a-mole where you shut down Dropbox for personal use, and then Joe's file share comes up, and then Steve's file share, and what have you. Right? It's a losing proposition to try to catch up to things like that. And then as well, the applications you do know about, there are changes, there are new threats, new application behaviors, just new changes to code on a daily basis. And this is the reality of where things sit today from an enterprise standpoint. We're moving to the cloud. We love it. It's got fantastic economic benefits, productivity benefits. It allows our IT organization to focus on what's really important and valuable, which is pushing the enterprise forward and helping to evolve the business. The challenge is that sort of the first generation tools in this cloud access security broker space were built for this notion of maybe there's 10 apps that really matter in the enterprise, and that's what we're going to protect. And so it's a fixed signature-based type of approach that needs to evolve moving forward, because you cannot rely on these signature-based techniques. And much like many of us realized over the last few years with things like desktop antivirus, we realized there that, okay, there's new malware every single day. And so if we have this signature-based kind of technology that we're relying on, it's a cat and mouse kind of game, and the vendor is always playing catch up, and therefore we're always behind in our protection. Same thing is starting to happen with the cloud. Maybe a cloud application is less nefarious than something like malware, but the constant evolution and change present in that cloud environment is similar in those types of environments. And that's where things like the zero-day control over applications comes into play. And this is where CASBs have started to evolve into this next generation of CASB support. And we've kind of mapped capabilities to a 2x2 matrix here. On the left-hand column, you see unmanaged applications. So these are things like perhaps Facebook or Snapchat, Dropbox, personal file sharing applications, basically any application that a user may access that is not governed and controlled by the IT organization, but still may be a source of data and threat, data leakage and threat risk, right? And that user comes in on a managed device. This is where things like Shadow IT Discovery, which is a visibility tool, have come into play over the last couple of years. But also more recently, zero-day unmanaged app control, which allows you to put some controls, policies, and parameters around those unmanaged applications when users accessing them from managed devices or from on a corporate network. Unmanaged app on unmanaged devices here, this is not an area where the IT organization should get involved in trying to control the application or control the device, right? That's my personal device, and I'm connecting to my own personal application. That's not an IT's purview, but what is an IT's purview is any corporate data that may find its way into that environment. And that's where organizations are using data containerization to actually wrap or control the data itself using things like a CASB. So for example, if I log into Office 365 and download a file to my local unmanaged device, perhaps the organization will choose to wrap that file in a rights management container so that can continue to use it, but the organization never gives up control or visibility, even if it ends up in my personal Dropbox account. So that's sort of the picture for unmanaged applications, right? We want to provide control over both the known apps like Dropbox and the unknown or future applications that we may never have seen before. And on managed applications, this is where most organizations have started to deploy CASBs over the last couple of years for apps like Office 365, Salesforce, and Box. This is around providing a comprehensive set of data and threat protection capabilities that are very deep and very granular in terms of the control and permissions that you can allow within that application. So once again, unmanaged apps, typically these are not apps that you know much about, and you want to provide some just sort of base controls and parameters to prohibit data leakage and prohibit those apps from being a proliferation point of threats getting inside of our network and onto our managed devices. And on managed apps, this is a very deep and granular control where you're managing permission. Your corporate data is supposed to be there, but you still need to put a lot of protection in place. So just quickly on unmanaged apps, as I said before, most CASBs have evolved to become a comprehensive data and threat protection platform for managed applications, right? Data protection does everything from contextual access control, so doing things like identifying a managed device versus an unmanaged device and maybe putting a more restricted access around an unmanaged device. So for example, a common policy we'll see is that if a user logs in to Office 365 from a managed asset, give them full access to Office 365. That same user logging into Office 365 from a VYO device, and we're going to block the OneDrive sync client because we can't think of a legitimate business reason to have, let's say, 10 gigs of corporate traffic, or excuse me, corporate data on that unmanaged device. And then maybe we'll allow the user web and email access, but in a restricted fashion where we're using other technologies like DLP to identify sensitive data going to that device and putting some controls and restrictions around that data transiting down to the device itself. So data protection is really all about taking a look at what data is going up into the cloud, what data is coming down to the device, and then applying policies or actions as a result of that. It may be restricted access based on the context, such as the device location. It may be applying wrappers around data that's downloaded to an unmanaged device, such as rights management or encryption, or maybe even redacting out sensitive content. And it may mean encrypting data before it gets to the cloud or before it leaves the cloud so that the organization continue to have ongoing control and visibility into that data even after it's moved into these other areas. Threat protection, most cloud apps don't offer anything in the way of malware scanning, and so here you want to protect against both known and zero-day malware. And of course, a cloud application can be a very convenient proliferation point for malware. I mean, if you think about a file sharing application, if I get a malware, if I'm a malware author or distributor, and I get a piece of malware into the appropriate folder on an end user's device, and that folder is synced or shared back into OneDrive and across the organization, now all of a sudden I've used an IT sanctioned application in a very convenient way to proliferate malware to not only one device, but to many devices across the organization. So threat protection is important. Identity, really the cornerstone of pretty much any cloud deployment, ensuring that we have identity best practices such as single sign-on and either all-the-time multi-factor authentication or step-up authentication, and as well the ability to do things like managing sessions on things like managed devices and ensuring that a user logged into Outlook Online isn't logged into that application for 2 weeks or whatever the duration is that the cloud application allows. That's sort of a big challenge as well. So integrating identity components into the cloud security strategy is key and critical. And then finally, visibility, right? Getting a full sense of what's going on across the entire cloud footprint, and importantly, layering in things like user behavior analytics and policy-based remediation, which means that you can take action such as a step up to multi-factor auth in real time if you see suspicious activity, instead of waiting for after the fact and looking at a report and then trying to do something about a data leakage event then. So this full set of data and threat protection capabilities is applied today with CASBs not only in those major SaaS applications like Office 365 and Salesforce, but across that long tail of applications that I talked about before, those tens of thousands of other applications the organization may have in place, but that don't have any security capabilities built around them, And then as well, internal applications moving out to infrastructure as a service platforms like AWS, Azure, and GCP. All of these use cases require sort of the comprehensive data and threat protection capabilities that I talked about on this slide. And so these are managed applications. These are those key critical applications where you're digging in deep, you're providing policies and control, and you expect sensitive data to exist in this ecosystem, and you want to put controls around that so you stay secure and you stay compliant. With unmanaged applications, it's simultaneously, I think, a little bit more of a straightforward and a simple type of policy, but also difficult, quite a bit more difficult as well, in that these applications, while managed applications may number in the tens in your organization, unmanaged applications may number in the tens of thousands. And so here, essentially what you're looking at is a set of capabilities that allow you to just put sort of coarse-grained controls over what a user can do. And frequently what we see organizations doing is making the decision to make SaaS applications read-only. And what I mean by read-only is that they allow data to come down out of the cloud. Right? Maybe you work at a financial services organization. You have bankers that are engaged with third-party clients, like a family office, or wealthy individuals, or startups, or whatever the case may be. Each of those organizations may choose to use something like Dropbox to exchange information with your organization. But the challenge is you don't want any data going up into Dropbox, because you're a bank and you need to protect all of your sensitive content, and Dropbox is not a sanctioned application. And so the approach that people are taking here is, let's allow that Dropbox. In the past, we'd say, no, we're not going to allow Dropbox. It made it very difficult for these types of people to collaborate with external third parties. But today, the answer is, let's allow access to Dropbox. But what we're going to do is we're going to make Dropbox read-only, which means that I can log in and I can get that data, that file that that client has sent to me, and download it. But I'm not able to take data in turn and then upload it into Dropbox. And this is a really simple policy that basically allows external collaboration or use of cloud-based applications without any risk of a data leakage event. And so people will do this with either sort of a blanket policy that says anything that we don't know about or anything we don't specifically whitelist, we're going to prohibit uploads, or perhaps they'll do things like tie in data leakage prevention detection capabilities, and so they'll say, okay, maybe prohibiting all uploads is a bit extreme, so let's prohibit all uploads that match sensitive content, as an example. And this is really a big enabler, especially in a lot of organizations that might otherwise be just blocking a lot of these cloud-based applications that could have some legitimate purpose. And the key to the technology here is this zero-day unmanaged app control type of capability. As I said before, it's no longer sufficient to rely on a catalog or a set of signatures that identify unmanaged applications. You absolutely must invest in technologies that are able to, on the fly, identify even those brand new applications that no one's ever seen before, and build some of these controls, not only the data leakage controls, but the threat protection controls around these as well. And so there are new technologies, these zero-day technologies will automatically use machine learning-based techniques to learn the leakage paths in any application. So for example, I log into a brand new app that nobody's seen before, I attempt to upload data or I download some data. These technologies will automatically learn these leakage paths and generate on the fly a set of capabilities that allow you to put controls in place. So your policy may say any of these applications or any unknown application we haven't seen before, we can allow downloads, but we'll scan those downloads for malware, so we're not bringing malware onto the corporate network. And we're going to prohibit things like uploads so that we don't have a data leakage event to some app that we don't know about and we don't care about. This is sort of a really interesting new area that a lot of organizations are starting to get into because it allows such a fantastically increased productivity environment, while at the same time providing a much better, much richer user experience while they're at work. Right? People want to use the cloud. They want to be able to occasionally log into something like a Facebook or a Gmail and check their email or make some social media updates. But at the same time, we have to protect against leakage. And so that's really kind of the key with unmanaged applications. Broad policies that are very quite a bit less granular in terms of control versus what we have with managed applications, but still nonetheless very powerful in preventing data leakage and threat proliferation. So with that, Mike, I'm going to turn it over to you to talk about one of our, or at least a couple of case studies here, and bring us home just under, hopefully, our 30-minute target for this Webinar Express. So, Mike.
Thanks, Rich. I'll see what I can do here. So, from a perspective of some example use cases here, we have this Fortune 100 pharmaceutical company, 80,000 users. Basically, what they were trying to do when they first talked to us was roll out Office 365. They had concerns over unmanaged device access, and they wanted to be a bit more permissive in their environment. They wanted to allow people to actually access Office 365, but control it. So when someone came in from an unmanaged device, they would be given access to the web interface, but they couldn't do things like install a thick client application like Outlook or like the OneDrive or SharePoint Sync client, where it syncs swaths of files and data and attachments and emails and all the sensitive stuff to the machine that then they can take away. So instead of that, what they essentially rolled out Big Glass to do was provide this agentless zero-day proxy technology for with an Ajax virtual machine, which we have talked about in a lot of other webinars and whatnot, for Office 365. And so what's happened there is twofold. When we're talking about this zero-day core, what we're describing is essentially a capability to detect these leakage paths and control them. And so what they wanted to do for these unmanaged devices was block those thick clients because they synced, but also block any possible download paths from the applications as well. So they use this capability to only preview documents and not be able to download copies. And that was kind of where things started. But then when you have unmanaged devices in the environment and you have zero-day threats and whatnot, you really need something that can detect and protect you against those leakage opportunities and those new types of APTs that you've never seen before. And so what we're essentially doing here is twofold. The zero-day core allows us to roll out support for the zero-day malware protection and the detection of new leakage paths and new upload paths and whatnot that occur for apps that are managed, like Office 365, and that's nice, because it's expanding all the time. There's something like 20 some odd apps inside of O365 today. Obviously, people use Outlook and they use Word Online and things like that. But there's all kinds of other apps like Sway and Flow and Teams and SharePoint and OneDrive and Power BI, and you just continue to keep naming them one after the other. And so you want something that can adapt and understand that the new types of risks and upload mechanisms for managed apps. But now, since we've been a successful deployment here for a while, and they've rolled us out, they're thinking, how about we use this new zero-day core capability for the unmanaged applications? So for unmanaged application control, they're looking at the same types of things that Rich was describing in the prior slide. They want to be able to do things like allow certain apps that are maybe not the sanctioned application that is Office 365 for file sharing, and control it. And sometimes I think there's twofold reasons for that. One is that this company, or just companies in general, are using some managed application like Office 365, let's say, for SharePoint and maybe Box. But then they're doing business with partners. And so if they're doing business with people outside their organization and they use different applications like Dropbox, and that's not the sanctioned Dropbox of this pharmaceutical company, then they can't really block it because the partner is trying to share content with them on their sanctioned app, which happens to be Dropbox. So they have to allow it. Essentially what you can do there is use the unmanaged app control to block things like uploads to Dropbox. So that while they can still interact and do business with these outside entities, they're not able to actually upload any content and exfiltrate it unless they use the sanctioned application like Office 365 or Box in this example. So you get kind of twofold protection with the zero-day core. I'll move forward to a different example here that's a U.S. health insurance company, 7,500 users, and what they're doing is it's kind of similar drivers, things like movement towards applications. This one, interestingly, although Office 365 did exist in the environment, the driver wasn't necessarily that. It was actually Workday. So from a Workday perspective, they wanted to protect Workday. And Big Glass was able to do that to maintain and meet their HIPAA compliance guidelines, as well as their zero-day threat protection concerns with Workday and Salesforce and other private cloud apps as well. So essentially, you're applying two things here again. The expansion of successful deployment of an environment which is regulated. A lot of times we see this desire to block and control apps in things like financial services and healthcare because they're more restrictive around what people can do on their networks, and that they're actually blocking things. So most commonly, what we get from a use case perspective when we start talking about this long tail of applications and this protection is twofold. One is they're using something like a secure web gateway or next-gen firewall or a WebSense URL filtering device to block unmanaged applications that are not permitted in the environment. But then when they have that use case like I was describing a second ago where a partner needs to share them something on their chosen application, they have to punch a hole in the firewall or in the web filter or whatnot to allow that traffic. So they want to programmatically choose and control the unmanaged applications in that manner while blocking upload of corporate content that shouldn't go there because it is not their application, it's not controlled by them, and also blocking things like threats from moving around the environment. And so this is pretty interesting, and the expansion also applies to other private cloud apps too. So if you have an application that you're moving to the cloud, you may want the same type of protections, be it managed or unmanaged for that as well. So the zero-day core here helps you out, and obviously the shadow IT capabilities are helpful too, to identify new applications you may not know about and you want to control that your users may be using on your network already. So I'll stop there. We're about 2 minutes from the end guidelines here from a 30-minute webinar perspective. Basically, the BitGlass's mission here is to detect new data and threat exfiltration or attack vectors across any application. And the real key here is if I find an application and my business unit is using it and it's managed, you want to protect it. And that's kind of the traditional thing you've seen from CASB so far. If you find other apps that are unmanaged apps that people are using, you can't really tie them in with single sign-on or to identity or other ways of managing those apps because they're not managed. They're not owned by you guys. But you may want to control those unmanaged applications. And so what you're really looking for is a CASB that can really protect any app in different mechanisms across any device, anywhere. And that's where we're focused here as a next-gen CASB. So thanks, Rich, for setting this up at the beginning, and I hope you enjoy the webinar. We'll answer any questions you guys might have, and appreciate the attendance.
Great. Well, thank you, Rich, and thank you, Mike, and thanks, everybody, for attending. Remember to please rate our webinar because feedback is super important for us. We want to make sure that we're tailoring all of our content for future webinars to your needs. And like I said before, the webinar is being recorded, so feel free to watch it on demand afterwards, and we hope to see you guys next time. Thanks.
Thanks a lot.